Hey everyone, I hope you're all very well. I am going to be talking about mitochondrial dysfunction as a cause of dysbiosis and imbalance in your gut microbiome, as well as intestinal permeability, aka leaky gut. Now, yesterday I shared a video where I talked about 3 supplements that can be helpful in healing leaky gut, and I'll add that video up here. But at the end of the video, I really stressed the importance in understanding that you're not going to heal leaky gut by taking leaky gut supplements. You have to address the underlying issues that led to the leaky gut in the first place. Leaky gut is always going to be secondary to something else. Now, this video is not covering all of those different things. We're going to be focused on one specific thing today. I will look at other factors that can contribute to leaky gut in later videos. So to understand this, we need to break it down. There's lots of different pieces that are all interconnected. So bear with me, grab yourself a cup of coffee maybe, and we will help you understand this as much as possible. So the first thing to understand is the large intestine is an anaerobic environment. It lacks oxygen. And that's fortunate because the vast majority of bacteria that live within our colon, our large intestine, are anaerobic organisms. They don't like oxygen. They're not going to replicate, they're not going to grow, they're not going to be happy if there's lots of oxygen in that environment. Now, we do have bacteria that live within the large intestine that can replicate, can grow, can be happy with or without oxygen. But we don't want many of those. They are or can be referred to as pathobionts, meaning they can be relatively harmless hanging around, but in the right circumstances, they can be problematic and they can contribute to various symptoms associated with IBS and IBD. So that's the first thing to know. We don't want oxygen in the large intestine. We need this anaerobic environment. Now, I guess the next thing to understand, and a question that might be coming up, is, well, how do we keep a low oxygen environment within the large intestine? And one of the answers is via healthy colonocyte metabolism. Now, the colonocyte is just one of the many types of cells that lines our digestive tract. You might have heard about them before because whenever we're talking about butyrate, we talk about how butyrate is the main fuel source for the colonocyte. Butyrate is produced via the fermentation of specific types of dietary fiber, and specific bacteria produce it. If you've done a health path gut health test, you will know that we look at some of these key butyrate producing bacteria to ensure that you have enough of them. Butyrate stimulates a receptor within the colonocyte that helps maintain what we call oxidative phosphorylation. Now, all you need to know here is that this is a metabolic pathway that it requires oxygen. So think about it like this. The colonocyte that's found on the lining of your large intestine is working via gobbling up oxygen to create its energy so it can go about its business, it can do its job. So when that's working well, oxygen is being taken out, and therefore we have this anaerobic environment, which is maintaining a healthy microbiome and also a healthy gut lining. Now, the problem is when this goes wrong. For various reasons, a lot of sort of pro-inflammatory insults, which we'll touch on in a second, can lead to a switch in the colonocyte. It can mean that rather than gobbling up that oxygen in an aerobic metabolic process, it switches to an anaerobic process. It's not using oxygen anymore to produce its energy and to go about its business. As a result, oxygen starts to leach out of the cell into the large intestine, where those bacteria that can replicate and thrive off oxygen do. The funny thing is that increase in these bacteria that can thrive off oxygen is actually discussed as probably the most common definition of dysbiosis that we have. It's a lot of these proteobacteria So again, if you've done a gut health test with us, we look at some of these guys. It's like Klebsiella is a very common example. We know that Klebsiella is one of the more common bacteria to overgrow in the small intestine in people that have SIBO confirmed via gold standard testing. So these proteobacteria bloom, and that is defined in the research as a microbial signature of dysbiosis. It's what we see in IBS very often. It's what we see in IBD very often. It's what we see in obesity very often. We see it in diabetes. We see it in a lot of other conditions as well, and that is published in the research. This bloom in proteobacteria and a decline in the butyrate producers. If you see that within a gut health test, you could start to speculate whether this process we're talking about is at play, that the colonocyte has switched from gobbling up oxygen to an anaerobic pathway, allowing oxygen into the gut, allowing these proteobacteria to flourish. Now, those proteobacteria are gram-negative bacteria. It's just another way that we can classify them. Gram-negative bacteria have something on their surface called lipopolysaccharides. It's an endotoxin. And we have a lot of research showing us that within the context of leaky gut, these endotoxins are able to travel across the leaky gut lining where they stimulate specific receptors. Toll-like receptor 4 is one of them. And that essentially initiates an inflammatory response in immune cells. And that can lead to a systemic inflammatory response. That could drive your brain fog. That could drive autoimmunity or certainly exacerbate autoimmunity. And the list goes on. So this is potentially a really quite common component to gut health. The next question, I guess, is, well, how can we bring this metabolic process back into balance whereby the colonocyte is gobbling up the oxygen again? And the answer is actually quite interesting. It's a lot of the things that we might already be considering to support gut health. So we obviously want to increase butyrate production. Butyrate stimulates the receptor on the colonocyte that essentially helps maintain this aerobic metabolism. Now, we spoke about that yesterday in the video. There are different ways of doing this. We first off need a healthy amount of butyrate producing bacteria. Now, we can increase these guys via the use of prebiotics, things like PHGG. We've got research showing us that actually omega-3 fatty acids from oily fish like salmon and mackerel and sardines may increase these butyrate producing bacteria as well. Exercise increases these butyrate producing bacteria. Types of dietary fiber, resistant starch, may do this as well. We spoke in the previous video about cooked and cooled potatoes and cooked and cooled rice and green bananas and things like lentils that might all provide the type of fiber that these bacteria love to ferment to produce butyrate. We could also consider, when the time is right, just to supplement butyrate itself for a short period of time to really try and flip this switch back into an aerobic process again. Research primarily in sort of in vitro, so laboratory studies and animal studies, have shown that things like curcumin, sulforaphane, vitamin A, glutamine may all support this process coming back online, shall we say. So we've got lots of things that we can consider doing from a dietary, lifestyle, and supplement perspective to help bring back healthy colonocyte metabolism. Now, when you look at this in the research, you start to see things like mitochondrial dysfunction is the driver of dysbiosis. And I think the exact quote is dysbiosis, and if you don't know that term, it just refers to an imbalance within your gut bacteria. Dysbiosis is secondary to mitochondrial dysfunction. We need to be taking care of our mitochondria as a way to take care of our gut lining and our gut microbiome. So there is some speculation also that as a result of this, maybe some of those mitochondrial nutrients may be helpful for some as well. Things like CoQ10 and L-carnitine, B vitamins, omega-3 fatty acids can be helpful for mitochondrial function as well. We're going to be talking about mitochondrial function a lot more in upcoming videos, but another thing to be mindful about when it comes to mitochondrial function is we need a healthy circadian rhythm. We need to have a good go to bed time and wake up time. We need a good eating window whereby we're eating maybe for 12 hours a day and having a minimum of a 12-hour fast overnight. So if you snack or graze in the evening and you don't need to support your sleep, which some people do need to do, then that would be an easy strategy that could start to improve mitochondrial health, mitochondrial function, and certainly improve gut health via different mechanisms as well. So I hope that's been helpful. I hope it's made sense. There's quite a lot there that I've tried to break down. If I try and summarize this, we have a cell that lines the digestive tract called the colonocyte. It should work via an aerobic metabolism, meaning it's gobbling up oxygen to produce energy, which means that in this case, we have a healthy, intact gut lining. Because remember, you might not remember, but appreciate that the lining of your gut is regenerating every 3 to 5 days. So in theory, if you are in relatively good health with your gut, in 3 to 5 days, you have a brand new set of cells lining the inner part of your gut. And I really love that statistic, that fact, because it shows you how quickly the gut will heal once the environment, the terrain has been addressed. But because of this fast turnover of cells and to help maintain an intact lining, there's a huge amount of energy that's required. And that is why these mitochondria are so important within gut health. If we have too many pro-inflammatory insults, poor diet, stress, antibiotics, potentially other types of medications like those non-steroidal anti-inflammatory drugs, if we aren't eating enough fiber, we are potentially limiting butyrate production. That impacts on the colonocyte. It might switch to an anaerobic metabolism. Oxygen leaks into the gut. Bacteria start to bloom, which means there's an increase in their population size. And those bacteria can start to contribute to all sorts of different issues within gut health. So that's the one sentence summary, I guess. If you have any questions, if there's something there that hasn't made sense, leave a comment below. I do try and get back to everyone. But hopefully this gives you another piece of the puzzle. Maybe it gives you a few different things to consider in regards to how you support your gut. And yeah, I hope it's been helpful, guys. I'll be back soon with another video, but hopefully give it a like, leave a comment, leave some feedback. It's really nice to hear from people and speak to you all very soon.